Okay, so my topic for today is going to be anatomy of a hack, the mobile edition. Yeah, this is more like a security kind of a talk, and usually security kind of talks involve a lot of theory. So I'll try to make this talk as less boring as possible, and since we are a little late on the schedule, I'll also try to wrap up early. So in about 30 to 40 minutes, we should be done with all of this. Yeah, I'll also take the opportunity to introduce myself. As I already said, I have started this community with Rajesh. This is the third meetup, and I think thank you to all of you all for coming in such a good number. And other than that, yeah, I am a senior engineer at Book My Show, and I take care a lot about the platform side, Gradle, performance, and all of that. And yeah, I've been working in the Android space for about 5 years now. Previously, I had worked with Rapido through an external consultant, but I think we shipped the app and we rewrote the entire app from scratch, and I think it does a billion writes in a day, I guess. Shaunak was in the team with me. It does billion, right? Yeah. So, I mean, it's more, but yeah, at least it does a billion writes. So, yeah, that's about me. Let's get started. First we start with these fundamental questions. First is the why, then is the who, and then is the what. So why even learn about security, right? That is the question you'll all ask me first, and definitely you should if you still haven't had that in mind. So we live on our phones, like literally, nobody can actually imagine your life without your phone. And that just means that this is a random stat I've picked from the internet that says that you spend 4 hours 37 minutes daily, even if you don't use Instagram or whatever like that. I mean, maybe it's less, but this is like maybe the maximum average that someone does. I mean, if I read that number, I wouldn't have even believed that, okay, half of or a quarter of my day is 1/6 rather of my day is on my phone. So, I mean, surprising. That is a 1 day per week. I'll just take it as the maximum number of time, but I mean, it's still surprising. That just means that's 6 days per month, and I've not gone ahead and calculated how many days in your life you're going to spend it. let's not make it that depressing. So I'm sure like all of you will have all of these apps. Not promoting Book My Show here, but I guess yeah, all of you all have all of these apps, and it's unimaginable, right, these days without all of these apps. So yeah, then as I said, we live on our phones, but then there comes an interesting question that even hackers love our phones, and they do it more than we do, and because they become the easiest to compromise, right? Like everyone uses that, and like you know, you want to deploy something, hack someone, your phone is your easiest target. And there just has to be one loose end in all of this change, and you're literally finished. Like, imagine people having cyber frauds, and like there have been so many numerous cases about mobile app hacks and all of that. So today we're just mostly going to look at not as users but as developers what we can do to prevent all of that, or at least to write safer code, make it difficult for the hackers. And yeah, another interesting stat about us living on our phones is that about 22,000 crores was spent in 2024. 25 stats are not available right now. So that was like 200% raise in the number of losses to cyber fraud. This is in India, and this is compared to 2023. And in 25, at least about 7,000 complaints are launched every day in the first half. I believe this number will go up in the second. Yeah, this is my personal favorite series, Jamtara. Have you guys watched it? Anyone? Yeah, I mean, you should give it a watch. It's like a little like Hindi twist to what happens, but the script writing is awesome, and it will give you like a real world overview of how phishing scams and all of that happen. And generally they originate from this place called Jamtara, and it's not very easily traceable. So you will just kind of actually discover the anatomy of how phishing calls and all of that happen. So yeah, just a shout out to that. Yeah, coming to the next question, the who. Obviously, the who are the faces behind the screen. So there is the category of all of these faces that are behind the screen. So there is a kind of people that are called script kiddies. As the name suggests, they are just kids. You know, they kind of just want to show off their skills to the world, and they're just copycats. So whatever kind of scripts that they get on the internet, they're just going to execute it. Let's say I go to GitHub, I pick up a tool that says, okay, I'm going to run a RAT or a remote administration tool on your phone and give you access to the camera. Script kiddie will pick that up and just run it and just say, okay, I'm a hacker. And mostly these guys are not behind any massive attack because they just want to show off. And because they use open source tools and scripts, they're very easy to trace back. And if it's a script kiddie behind an attack, our cyber teams are very, very capable of getting back to them and penalizing them. The other type of hackers are activists or organized criminals. So as their name suggests, they are some kind of activists that fuel their agenda using hacks, and they are also driven by a motive which can be either social or either political. Generally, it's very easy to brainwash people on both of those terms. So these are those people. And they are mostly professional, by-the-book kind of hackers. They've usually learned how to hack and undergone courses and all of that. And they usually operate by a by-the-book mechanism. Okay, I've learned it this way, I'm just going to do it this way. Nobody's going to think out of the box for these type of people. And as I said, these are like intermediate level folks. So yes, they can write their own scripts, they can write their own exploits, yes. But not like really would they usually do it. But yeah, they are capable of doing it. The last ones, I guess, are the most dangerous type of hackers that are not very easily available around, and these are the state-sponsored hackers. So this is not a single hacker, but this is like a group of hackers. So what happens is these people are sponsored by the state. By state, here I mean this could be the state government or any rich kind of organization that has a huge amount of money and is powered to bring down someone else. They can be funded by such governments or state in general terms, and generally when a cyber war happens, generally they are the ones behind it, and they are super rich. They own like labs and labs of computers, and they have super heavy computing power. So if you've ever heard of like denial of service attacks, generally these people are behind that. So yeah, I mean like even BMS during the Coldplay time, I mean this is out there in the public. BMS had suffered, I guess, for around 5 or 10 minutes of a DOS attack, and was 7, right? Yeah. So it was a 7 minutes of DOS attack. What happens in this DOS attack is your servers are kind of literally jammed with random requests from random anywhere. So that actually means denial of service, like your server won't serve it. And what we had to do is we had to go and manually block all of that. Kudos to our security team that actually did it like really quickly. So yeah, I mean this is information is out there in the public forum. I think Ashish, our founder, said that in one of the podcasts. So yeah, I mean it's out there. Yeah, the what now? The third question. So one thing that comes to the mind is what could be the modus operandi of the hackers. Basically, in simple terms, what would be their operating principles, or what do they already know of, or what can we know of as mobile application developers, so that we or our users don't suffer the fate. So first one is OWASP. So you must be thinking, okay, another cool acronym, like they're super cool around these days, BRB, whatever. I mean, yeah, this is just one of the acronyms, and this is the sign, this is a WASP. I don't know why they named it that way, but yeah, it stands for Open Worldwide Application Security Project. So basically, if you see the name, it's like a worldwide thing, and it's also open, it's open source. So basically it's like an organization and it's non-profit. So what it does is, usually there are people who actually want to improve software security. They've got together and they run it. They are funded by governments, they are funded by national security agencies in America, and I think India also funds this organization. Governments come together and do it. And usually, today I'm going to also talk about the top 10. So basically, the top 10 is like a list of the most critical risks that they've identified for a particular year. So for the web platform, this updates every year. But for the mobile platform, it's less frequent. And the last updated list of top 10 risks is from 2024. So uske pehle it was in 2016. So I guess the interval is 10 years now. So you can imagine that over 10 years they keep seeing on the same kind of vulnerability, and people keep doing the same mistakes, and hackers keep exploiting all of the same vulnerabilities. Like they don't even need to update the list in like 10 years. So I mean, that just speaks volumes about how careless we are about application security. So yeah, I mean, just let me briefly introduce this list. This is all the lists. I mean, I don't care that much about the name because, as Newton said, naam mein kya hi rakha hai. So I mean, instead of making this like a boring theory lecture or something like that, I mean, let's just name them some animals in the zoo. I think it will be easier to work it out that way. So just giving them random animal names, because yeah, I mean, nature never bores us. So here you go. Yeah. So let's start with the first one. Yeah, trust me, I would try to make this as less boring as possible. So the first would be the elephant in the room. That is your improper credentials usage. So basically, by a credential by definition usually is misunderstood by a lot of people, and people think that a credential is only a username or password, but it can be anything that can uniquely identify you. So in an Android developer's world, you could come across API keys, then you could come across secret keys, some JOT tokens, client secrets, hashes, and lots of stuff. Like Google Maps is almost something that all of us uses. AWS is another thing, Firebase keys, lots of stuff. So those are what I call as credentials over here, and improper usage just means that we have kept them in such a way that it is very easy for anyone to come and just kind of pick it up and just misuse it and go rogue with it. So I'm presenting a case study here where we are seeing hard-coded API keys in apps, and there is a specific app called Bounce Daily, though this vulnerability has now been patched. I mean, Bounce Daily is not very famous, but I think if people in the Pune circles know about it, it's like a two-wheeler application, like an electronic two-wheeler application, and using which you can book electronic two-wheelers on rent. I think their office is in Kothurud or something, but they're Pune-based company. And what had happened is their AWS console credentials were hard-coded into the app. As a result of this, this looked something like this. Let's say your access key starts with this thing and they've just left it in the app. And usually I think why it would have happened is maybe someone just started off the app and they did not know that, okay, maybe this app won't scale or something like that, you know, just get it to work. So someone just left it around in the code and it went rogue, and it cost them like a lot of monetary losses when it actually scaled and all of that. And people started exploiting their S3 buckets and uploading random stuff, increasing their cost and whatnot. And to make matters worse, what if they had deleted user data or some important documents? So basically, this is how a hacker would have operated, basically the anatomy of this kind of vulnerability. First of all, he could get the APK file or IPA from any available public source. For people that don't know, there are a lot of websites that give out APKs. Thankful to split APKs, it's actually difficult to get single APKs these days. But at that time when this vulnerability was there, APK getting is super easy. Just get it from any kind of source. Just decompile it. Anyone familiar with decompiling tools for Android apps? Anybody has done that by any chance? Give me raise your hands.
I remember one website I used called Java Decompiler.
Yeah.
That is to take APK and take the source.
Yeah. So actually, there are JavaScript tools behind this that do that. But then there is an open source tool called JDX or JADX GUI or Ghidra. So Ghidra is something that NSA or America's National Security Agency maintains, and this is like an open source thing. JADX GUI is a bit simpler. Like this is your on-device solution. You won't need a website to go and do that. You can just say JADX GUI or APK, and it opens like a GUI as similar to Android Studio, and it will show you all the code that's there into your app. So basically any hacker can come and use that. This is again an open source tool, and there are a lot of people that work really hard to maintain it. Maybe for the white hat purposes, where you actually need to know what's there in the app, or maybe you are trying to decompile your own app and know what's going around here before any hacker does it. So what they do is they will then just go and search for patterns. Like these are very common patterns. Like a variable called password is obviously going to be called password and not something else, or secret API token or whatever. I mean, like it's very easy to make a calculated guess कि let's say आपका credential कहाँ रखा हुआ होगा. So generally, and this is also a known thing in the hacker space, that usually Amazon के credentials start with AKI है, and all of the Amazon credentials usually start with all of that. So if I just do a random reject search in all of your code, and if I find that, then I mean it's a big thing for you. So yeah, coming to how to prevent it. I mean, you already know of all of this. If not, then please hear it again. You should never hard code anything in your app, even if it's just for convenience. If your code by mistake happens like this, and if you're lazy or it just skips the code reviews, then obviously you have incurred a big monetary loss for the company. For the senior engineers, please keep an eye out on all of the hard-coded credentials in your application's code base and PR reviews, and if you find something like that, please get out of it immediately. Also, try to use the platform secure storage wherever possible. There is a new encrypted shared preferences library, that is Android X. I think previously everyone used shared preferences straight up, and I think it's now available, but people still haven't moved to it. I guess people just rely on shared preferences. So shared preference is so vulnerable that a rooted phone can just get access to your current shared preferences and just play with it. Let's say if I log in the user and I keep all the data related to the session in shared preferences, I as a hacker can just root my phone, take your app, just modify the shared preferences, copy anyone else's token, and probably your app will work as if it signed in with some other user's data. If there have been cases where shared preferences has been manipulated that way as well. So don't just leave your shared preferences in plain text. And if you're an iOS guy, keychain is like a really good thing, and it syncs across like all the Apple platforms. So that's another thing. And passwords are like really good thing these days Apple that is doing. And also try to use temporary tokens and provide finite access. Just don't give unlimited access to anyone anywhere. This is mostly from a backend perspective. If you're logging the user, don't use infinite validity JOT tokens or on those terms. And the best practice is always to make your backend the broker and ask it to manage all the keys. Let's say if you want to manage access, just create an API for it and just ask your backend to manage it, and don't do it yourself. Maybe ask your backend for some kind of validity token, and just verify that it's you that's getting the token, and then after that just do whatever operation that you want to do, and your backend will just kind of revoke that token once a finite timeline goes away. So next up is the next animal, that is the tiger in the room. This is for inadequate supply chain security. Again, name doesn't matter, but yeah. So it said that in any kind of security system, any security platform is only as strong as its weakest link in the chain of dependencies. So your app happens to be part of the same platform, and humans are always going to be the weakest part of any kind of security because they're the easiest to manipulate. You can always teach machines to do something, but humans don't learn, and they can always be manipulated emotionally or whatever way. So they are always going to be the weakest link in your chain of dependencies. And just because a library is super famous or has stars, it doesn't mean it's secure. You just need to do a thorough checking of that before actually integrating it. The next case study I'm going to present will actually surprise you. And in an ideal scenario, what happens is your code should actually be free from all third-party dependencies. But again, that's an ideal scenario, and to actually build anything, you need a good amount of time. And we cannot reinvent the wheel always. So we will always depend on third-party dependencies. But wherever possible, just try to avoid third-party dependency and just try to check all the code that you write. In the AI age, it's also very important to verify whatever AI write for you and not blindly just copy paste it. Super important for senior engineers as well. So yeah, presenting the case study, that is this vulnerability was found in Google Play Course library, and this is called a path traversal vulnerability. So Google Play Core is super popular, and since all of you might have used it, and it's possible that you don't even know that you use it, but almost all the apps use it for some kind of stuff, like maybe download a split APK. Like for example, Paytm, if you open some kind of feature, it downloads a new APK or a new feature module on the go. There are many apps that do it. It's powered through this Play Core library. Provide in-app reviews. Let's say you're asking your user to kind of provide a review to your service. You can do that with Play Core again. Lots of services possible related to Google Play services. So this is actually now deprecated in terms of multiple feature-specific libraries, and I mean there are separate libraries for each of these use cases, like in-app reviews, rating, and all of that. But I mean, like, let's just for the sake of doing it, I just want to say that libraries even as famous as these can actually have vulnerabilities. So what exactly is this path traversal vulnerability that is a part of this inadequate supply chain security? So as I said, supply chain means that maybe you don't make the fault, but someone in your supply chain does. So this could have been the weakest link in your app, and it's from Google, like what even? So you all know that by default we can access only a certain parts of the app, Android system, or inside your app, right? Your app needs to get the read external storage permission, which was again deprecated, but yeah, it's even stricter now, I guess, following Oreo, where you have scope storage and all of that. Android 10, 11, something like that, not Oreo. But yeah, you know the basic structure of paths as well. They're just separated by slash. So something like this could be the path of your download folder. Let's say you initiate something on the internet, download it, and it's actually on this path. So if I type .. slash, I mean all of you are familiar from Linux background, it just means that you go up one level, and due to this vulnerability, this library allowed it access some parts of the Android system, and using this .. slash, someone could actually go up one level and just keep going up to the root directory. So what happens is your app literally now has access to the root directory, and it can do like really harmful stuff. So then what happens if a hacker operates using this vulnerability? So let's say there is a user that happens to have this victim app that uses this Play Core library, and then they install this little tiny malicious app called battery status. You should be very careful about all of these apps that check battery statuses. They are usually viruses. Nobody just ships an app to check the battery status on the Play Store. I hope it doesn't happen anymore, but like there are people that just just download this. I mean, like just make people download anything, they do it. But yeah, for the sake, if someone does it, and what happens is, so this app called battery status, it doesn't check the battery definitely, but what it does is it downloads some malicious script and it saves it to the victim's root directory just by using this path traversal vulnerability, where it can actually go to anywhere in the system. And the next time what happens is, when you open the app, your app will definitely sing happy birthday to you as the script wants. So yeah, I mean that's pretty much how a hacker would operate in that kind of vulnerability. So yes, how would you prevent that again? So generally there are a lot of automated tools that keep checking your project's dependencies, and they scan public databases for all of these known vulnerabilities. known GitHub repository or a bot that keeps checking it is Dependabot. Most of open source projects and even private projects use that. What it does is it keeps notifying you of all of these vulnerabilities, and if your dependency has another update, and just kind of have it. It's very easy, just like a 1 or 2 line change, and that's it, you're done. And what it does is raises a separate PR for each kind of dependency update. So if you haven't checked it out, please definitely check it out. Then there is a tool called MobSF, which is like a pen tester's best friend. It is like a framework that actually gives you like a all-in-one kind of tool. It just checks all the vulnerabilities to the extent of actually fixing it as well. Like if it's just a one-line string change or something like that, MobSF is going to fix it. And you also need to avoid using libraries for trivial tasks. Let's say I need to create like a section recycler view or something like that. Why would you go and add a library? Easiest way out for you, if you are a junior engineer or someone that doesn't know all of the logic, just go read inside what that library is doing and write your own implementation. That will be your good practice, and get your code reviewed by your senior peers. Why even have a library for something like that? So keep avoiding libraries for simple tasks. Yeah, as I said, just get it verified by your security team or senior peers in your team. Yes. So the next slide is the lion in the room. Again, another animal. This is for insecure authentication and authorization. So this security or the category is about the flaws in the digital gatekeepers. So any kind of gatekeeping application where, let's say, there is some kind of application that just authenticates you, authorizes you, that is something I call a digital gatekeeper here. Or maybe this kind of system is just inside in your app. So your app is also a digital gatekeeper. So there are 2 aspects to this. One is defining what actually authentication is. So basically authentication means that proving who you are. So let's say today I'm just giving my fingerprint to my phone. Your phone already just knows that it's you, but it's just first verifying that whether it's actually you or not. So essentially you're just proving who you are, right? And coming to authorization, you give, or you decide rather, like what you will do once you're authenticated. An example this would be that a regular user in your app won't be able to access admin functions. You will log in with a specific email. The app checks whether it's eligible to do certain kind of functions. If yes, it allows it to do it, otherwise it doesn't. So that is authorization. This is like a pretty basic understanding, but I just thought that I'll just put it forward. So yeah, for this I would like to present the case study for a messenger called as Element. So I don't know if you all have been famous or not, but Matrix is like a peer-to-peer network that was created like some time back, and it is supposed to be a secure communication using the decentralized mechanism. What happens is for chat apps, you usually need a server, and that server, if not configured correctly, can store all of your data, and there is also a chance that it can also intercept or read your data. So there is a lot of these kind of protocols coming in where it's just decentralized, right? There is no involvement of the server to actually communicate between 2 parties. So Matrix is just one of that protocol, and Element happens to be an Android client for it. So basically, Element enables you to use the Matrix network on Android. So something like this, let's see, it's there, and you've always had this dilemma of doing, what do I put here? Do I put true or do I put false? So how many of you all know what does true mean or what does false mean over here? Yeah.
If you export as a true,
Yeah.
any other activities from other applications,
Yeah.
and they can see.
Yeah, essentially, yes, correct. So generally what we do as a good practice is we always keep this as false, right? We want to start with the principle of least privilege. So generally I guess Android Studio still, I guess these days gives you a link that, just don't set it to true. But back in the day when this actually came out, people were really confused, what do I put in, true or false? But usually it should be false. If you Yeah.
For launcher activity, it would be true, right?
Yeah. Because it needs to be launched by a third-party launcher, right? Yeah. So coming to this vulnerability as well. As I said, this is picked from like Element Messenger, and here if you see, it is a launcher activity that is set to true. But what happened is in this case, as I said, this needs to be true because any kind of third-party launcher or system launcher should be able to launch it. So basically, launching this from an external site other than your app. So what happened is this activity was supposed to be protected by a PIN, and only authenticated users were supposed to go to it. And if this is exported, actually anybody can launch it using ADB. This is the case for all launcher activities. But what happens is, in this case, it turned out to be a proxy activity. A proxy activity is just like your deep link activity. Let's say you have a singular point in your app where it actually intercepts all the deep links and then decides where to go. So what happened in this case was something called as an intent redirection vulnerability. So this activity would just actually accept any kind of intent and just launch it. So let's say you could launch anything in the app. If you could just decompile the app and know where you're going to go. So let's say if there is some section, as I said, if it's supposed to be protected by a PIN, and this activity, which was the proxy activity, which was exported as true, if it was launched with ADB and it was given some kind of intent that go ahead and launch this screen, it would just launch it. So I think there were two things to it. Launcher activities can be exported, no problem. But there was another activity that was exported as true, and it used to accept intents randomly. There was no check on the intent, and malicious users could come and launch anything in the app. So basically two things happened here. One was intent redirection, and it was insecure authentication and authorization as well. So coming to the question again, how do you prevent it? So you should never trust any kind of external intents. You should always treat them as hostile and always sanitize it. Just have finite checks, or just ensure that they are just going to go to somewhere controllable or somewhere reliable, and you just know that who is going to launch it. We have protected apps, I think protected intents as well. So you could use something like that. And as I said, you should always set exported false for all the activities that don't need to be invoked by other apps. There might be a typo where you just might leave this as true, but don't do that. Just ensure that you don't do that. And yes, you should also centralize authentication and authorization at a level which is not just bound to the UI. So that PIN screen was just the UI kind of layer, right? There was no centralized authentication layer to protect it. But if it would have been another layer, or like let's say second layer to protect it, I think that intent redirection wouldn't have happened. So yeah, I mean, zebra in the room, the next one. The insufficient input and output validation is what we're going to deal with. So again, if your app actually trusts anything that is input to it, maybe that chances are that you are like a victim of this vulnerability. So it is just like a government office that accepts any form without even checking if it's correctly filled or completely filled. So I think something like this just turned out because some government office actually was a victim of some kind of input-output validation, or maybe some system didn't do it. Let's assume this was some Android app. But yeah, I mean, definitely, there has to be a story to it. Yeah. So let's go to the case study, and for the case study, I would like to present SQL injection in VLC for Android. How many of the folks familiar with SQL injection? Oh, nice. Just 3. Okay, 4. Okay. So I'll just go ahead and explain SQL injection to the other people. So it just means adding some random SQL queries to any kind of plain looking text. Okay. So the definition is on the board, and it actually makes the SQL database or the system perform SQL queries that it shouldn't be performing. So I'd also like to give the example how VLC was a victim of SQL injection, or indirectly like insufficient input-output validation. So basically VLC has a library, VLC has a feature where it can scan your entire kind of storage for subtitles, for video files, it all accumulates that and it puts it in the app. This is true for all kind of video players, but VLC is a special case because it was suffering with SQL injection because it did not sanitize it. So sanitize here is a technical term where it was reading anything and doing anything based on some kind of code. So what happens is, let's say if someone names a file something like this, like let's say mymovie.srt. So srt is a subtitle format if you don't know, and I just put dash dash drop table media next to it. And if the database executes this query somewhere where it's actually, let's say the developers configured it to read all the data and just put it on the database and just don't care about the query. And if this query kind of runs, the database actually executes this without even thinking about it. And imagine if while actually reading the media in your app, your SQL just starts deleting media. And I mean, that was mostly what happened in SQL injection. I mean, all of this stuff is documented on GitHub and they've actually acknowledged it and fixed it. VLC is an open source project, so they always keep coming up with fixes, and people are very kind to actually test it and just not exploit it, but get it out in a fair way and get all their kind of compensation. The other day, I was scrolling through my LinkedIn and I found something like this. There was someone, a product designer, I guess, who suggested that maybe PhonePe could come up with something like this. Like I just go and kind of just type out some kind of query inside the text box, and PhonePe would just magically compute whatever is there and just decide the amount. I mean, this is so helpful for scenarios where we want to split and we just don't want to open a calculator and do it. But this is exactly where something like let's say someone types out some JavaScript and this is going somewhere to the backend, and people just accept this without even checking what's inside there, and this blows off something. So this is like a classic place where SQL injection can be performed. This is mostly executed on backends, but this can happen to your apps as well, since your apps usually use the SQLite database via Room or something like that. I think Room generally sanitizes the queries, so this is not very relevant right now, but there are some people that still use the old SQL statements and all of that. So if you are, I guess for SQL, correct me if I'm wrong, Shreyas, there was a parse statement or something like that, right, for SQL? जहाँ से अपन we used to query and all of that, it creates a query into a structured or type, I guess type safety based format where it used to do it. So I guess you can use that as well. I guess it's called parsed values or something like that. It is a function provided by the Android SQLite wrapper. I think you can use that as well. Yeah, so how do you prevent something like this from happening? So you should never trust anything which I already said, that don't just trust your inputs in your app blindly. And if it also means anything that is coming to your edit text, just don't trust it. And first of all, just like make sure that if you just want numbers, just allow the keyboard to type 0 to 9 only. And there's a very easy way to restrict it, just type IME options or something like that. It's very easy to do it. But just remember that maybe you are a victim of all of this. So just be careful when you're doing this. Yeah, and if a web view in your app is supposed to display only HTML, we have a method called set JavaScript enable. Usually what we do is we set it to false. You should never set it to true unless we are actually sure that what we are going to do, because anyone can come and just make your web view load random HTML and just load random JavaScript that can do anything. And yeah, always sanitize your inputs for SQL injection, that is, drop all of this vulnerable stuff, script tags or drop queries, or just remove all kind of SQL tags and only accept alphanumeric stuff. Yeah, the next one is the horse in the room, that is your insecure communication. So this is again not something where your app is directly affected, but maybe the network that your app is using to communicate is not very reliable. So what can be done in this case? But yeah, before that, I would like to ask the audience, how many of you all know about the MITM or the man in the middle attack? Oh, just 5. Okay, 6. Yeah. So basically, I'll also tell you all about the man in the middle attack, and that is that, let's say if two people are communicating over here, and just for a simple sake, if someone in between is going to intercept that communication, that guy is actually the man in the middle. And how this happens as an attack is, let's say you're communicating from your app to your backend, and it's not encrypted, it's over an HTTP channel, or it's not protected by a certificate, or it's not going on a valid network. Anybody can come in and just watch what kind of traffic is happening. I mean, in our day-to-day lives, we might have done that using Charles proxy, or maybe if you've used tools like Chucker do the same thing. Like they just do it in a first-party way, but there are third-party bad actors that can actually do this, and that is when an MITM or man in the middle attack happens. So, as a case study, I'd like to present here a session replay attack in the Starbucks mobile app. So basically, I'll also tell you all what session replay is. It's like just another man in the middle attack, as I said. But we want to kind of replay a valid user action for some kind of malicious purposes. So in this case, what happened is, let's say if someone wants to transfer that gift card amount to someone else, this was being done over an insecure network. So Starbucks did not have HTTPS in their initial version. So what happens is a hacker can come in and just check this request and see what exactly is going through, what are the details or whatever is happening. Maybe through all these kind of tools like Charles proxy, burp suite or all of that. And just get hold of something called as a session token. So session token is just like a token that identifies your user, your eligibility, your authorization and all of that about the user. Then they could use this token to perform this transfer unlimited times. So let's say I am the hacker and you are the person that actually has the valid gift card and you have an amount of 500. So what I'll do is I'll just pick this amount of 500, I'll transfer it to me, I'll grab hold of 10 such users and just get 5,000 into my account. And just do this randomly, just based on intercepting one user request. Just kind of apply this to anywhere. So this is what a session replay is. Basically you're replaying what's happening in a session. So you're kind of doing some forgery with the backend. So who is to blame here? The question is that, is the server or is it the app? I think it's both, but it's the app first because it doesn't encrypt the data. If it would have encrypted the data, at least it would have made it difficult for the hacker to at least know what's happening in this app. So yeah, again, coming to the question, how to prevent it. Again, certificate pinning. I guess most apps implement this, and if you haven't implemented it, please go ahead and do it. It's a bit long process. I'm not going to cover it in this talk, but I mean you can Google it, and if you're using something like OKHTTP or retrofit or something like that, it's just like 10 lines of change and very easy to do, and definitely do it. So it's just like kind of saying that, okay, I'm giving a certificate for a transaction. If you don't hold this certificate, I will not let you perform this transaction. So that is essentially what certificate pinning is. And as written here, fake certificates are just going to terminate the connection. And again, similar advice, just use time-based tokens and just have them for a finite window, let's say for 5 minutes. Use anti-replay mechanisms. This is for the backend. So let's say if I want to initiate something like a transfer, what I can first do is I can ask the backend to give me a nonce or no once. This is like a combination of two words saying no once. So that just means that it will give you a unique identifier that is just unique. Like it won't be replayed again. So before initiating the request, you ask for this nonce. And then when you initiate the request, just put this nonce into the transaction so that at least the backend is aware that this is a unique transaction and nobody is going to repeat it again and again. So yeah. So the rhino in the room, inadequate privacy controls. So if you are someone that's too lazy or like to know actually what you ask from the user, or like you're really aggressive with it as well, then you're definitely playing with fire. And maybe if you ask so much and then if you don't even take care of it, so definitely again you're going to play with fire. So it also includes leaking sensitive data through logs or some kind of insecure storage. So people don't even bother. They just keep logging random stuff into their production apps, and all you need to do is decompile it and enable logs in the application, and you will just see random load of stuff, errors, tokens, and whatever being just thrown into it. So there's something like this. If you don't have proper privacy controls in your app, there's just a gate, and you can just go anywhere, and this gate is of no point, and this is what basically your vulnerability is. Yeah, so there are numerous apps. There's no specific apps for this case study. I mean, like most apps or many apps that I see are actually guilty of this. So let's say if you are an app that asks for a location permission, just to figure out, let's say, the nearby people for a particular user. Let's say your Snapchat just figuring out on the map, like who's your friend. Or maybe you're uploading some photo and you use the location to tag it, just to help people tag it. So what happens is people just store this insecurely. They just store it in plain text in shared preferences and just forget about it, or just log it. Let's say it failed to log. So you just log, I did not get this location. Or when you get the location, you just log it, okay, I got the location is this. So anyone can come and read it, right? So this is about that. So the Air India app someday just left all the PNR information this way, and it also wrote session tokens to shared preferences. Again, this is documented on the internet. It's open. You can just Google and just find that out. So I mean, like even big apps as these are guilty of this. So again, how do we prevent this? There is this principle of least access, that is the first principle of security, and that just means that only ask as much as you need, and this should follow even down to the level of declaring a variable. So if you are doing something like this, yes, this is correct, but if you are doing something like this is wrong. So first of all, you just start with a val. You don't start with a var. You start with a val, and then if you actually need to modify it, then you start with a var. Even Android flows of lints saying that, okay, you don't need to make this a var. Why do you make it a var? Just make it a val. That's it. I mean, all PI, if you are in a security background, you would have heard about this term PI a lot, or analytics or something like that. It just means personally identifiable information. It should be encrypted, or if it's required for a long amount of time, or just store it for a finite amount of time and just clear it or log out or other times as necessary. Yeah, and also don't forget to encrypt aggressively, as aggressively you ask for the information. Yeah, and just don't throw out information in logs. If you have a legacy code base that just throws out stuff in logs, there are rules for ProGuard that can strip off log rules. I have also posted about them on LinkedIn. I'm not sure if I've included that here. No, I've not included that here. But yeah, I can include that again. And it's very easy. It's just 4 lines of code where it just strips off all the logs from your database. So any kind of log.d, log.i will just be removed in all of your production apps. You don't need the logs in production apps at all. Yeah, the monkey in the room. The app. Okay, sorry. Yeah. So what happens is, again, very similar, that app binaries now can actually expose commercial API keys. This is like pretty similar to the first one. So this just says that if your app is not directly vulnerable, but it gives off some clue about your backend being vulnerable, then that is another kind of problem. So like this is what the vulnerability is mostly about. And yeah, I mean, lots of small businesses just say, I don't need to worry about cybersec, but it's always a dilemma to tell them. Yeah, so if someone wants to kind of exploit this, so license verification bypass was like really common in a lot of apps when routing was the thing or custom ROMs were the thing. Like, I don't know if you're from around that age when you started doing Android, then probably you know about this. So let's say if there is some kind of code that checks if the user has like a paid or a premium version for something, and if it looks something, okay, yeah. yeah, if it looks something like this kind of if else, as I said, just someone you will, some kind of decompilation tools will get access to this and just set this flag to false and just go ahead with it. And there was a tool called Lucky Patcher. I am not sure if that works anymore or something like that, but this was like 2-3 years back. So Lucky Patcher had like a list of all apps that had all of this kind of checks, and it created all of that into an automation. So all you had to select the app, and Lucky Patcher would apply the patch for you. So it was like a patcher. I think right now there is something called as a revanced community, which works on patching YouTube. Like people are super annoyed with the YouTube ads. So I think revanced works on a very similar mechanism. It just finds out what kind of code has all of this if else, just tries to get rid of it. I mean, obviously the mechanisms have evolved, but the principles remain the same. If you haven't checked revanced, go ahead and check it out. They're doing a good job. Yeah, how many of you all know this? Yeah, so let's say if Candy Crush, if I'm using Lucky Patcher, I can just level up using Lucky Patcher if it's just stored as a string. And if it doesn't have any kind of server-side validation to it, let's say some level logic is right into your app, so the Lucky Patcher will just kind of just increment that number. I mean, Candy Crush was susceptible to Lucky Patcher. I'm not sure if it is anymore, but yeah, it was. So yeah, again, how to prevent it? So you shouldn't store any kind of license checking code locally on your device. Use your backend always to give you the correct and the most up-to-date or relevant license status. Don't do all of this if and else at all. Just use tokens and all of that. Lots of mechanisms available. OAuth, JOT, whatever. Yes, and always obfuscate your code. I mean, this is the best practice that even Google recommends. Like, just use ProGuard. Just randomly, just make the hacker's life difficult. Like, why do you want them to be so easy? Like, just yeah, and you can also use solutions like the Play Integrity API to check if the signature of your app is valid or not. So one of the first steps to actually start modifying or do some kind of forgery with your system is that your user, the attacker takes your APK, it does its modification and then it signs it with their own key. So when your app has some kind of integrity checks to it, it will not allow it to be installed or the functionality internally to be work if this kind of signature mismatch happens. So Play Integrity just kind of makes it simpler for all of these use cases. And generally, I guess recently I also saw a toggle on the Play Store where if you just check that toggle, it also includes a binary which checks that if your app is installed from the Play Store or not. So if someone is actually re-signing your APK and deploying it, definitely it's not going to come from the Play Store. So that is like avoiding a big part of tampering or something like that. So if you just tick one toggle, Google is dynamically going to include that binary in your app, and that is like so useful. And yeah, Play Integrity is always there. So yeah, I think getting done. Yeah. So the panda in the room, that is the security misconfigurations. So if you imagine your app like houses and your data is the treasure that you keep in it, and if you just leave your key under the doormat just so that your loved ones know about it and there's someone who's spying it, and if someone else sees it, you're just waiting to be rickrolled. So don't do that, even for house keys. Yeah, so coming to the case studies, publicly writable Firebase database. So this was also like a really big vulnerability back like 2-3 years back when Firebase was relatively new and people didn't understand what exactly has to be done with the Firebase database. So if you have ever written to the Firebase real-time database or something like that, you would see that there is a way of configuring the rules, and you can just decide like .read to and .write to. This just means that just allow anyone to do it, and maybe you all still have done this on your pet projects or something like that. But generally what happens is complicated projects or like prod level apps, scalable apps just put some kind of checks that okay, if user.uid equals something, then only allow read or something like that. So authorizing or authenticating it securely. So in this case what happens is the attacker can simply find your Google services JSON that is just there in your app, it's not obfuscated, nothing has been done. And with this they can also guess your database link. So your database link comes in this format. Let's say I picked the project ID from your Google services. I just append firebase.io.com that /.json. And if basically the rules are configured as above, what happens is that your server, your Firebase server will give you all of your database right away. And if someone is smart enough, this was just a get request. If someone puts in a put or a delete request, he can also mess with your database, like just with the simple Firebase link. So you need to be very careful while configuring such rules as well. And yeah, again coming to how to prevent it, you need to disable the debug mode in the production. I think Android Studio already does that. And make sure all the debug related checks are secure. You need to audit your database rules regularly, perform security audits, just keep checking that okay, the rules that you have defined, are they relevant anymore or do they need to be updated? Yeah, and put your server through proper authentication authorization mechanism, have HTTPS certificates and all of that. Last but not least, the dolphin in the room, that this is the insufficient cryptography. So this actually isn't the lack of encryption, but we've already covered lack of encryption before. But this is more about that having like a false idea that okay, I have done my encryption and I can now go ahead and tell anyone okay, come hack me. This is not about that. This is like usually about two things. One is like using outdated algorithms. Let's say if you use some algorithm that's already whose exploits have been public or people just know how to break through it very easily with some computing power or some edge cases, something like that, but very easy to break. Or making some implementation mistakes like not doing it correctly via code or just leaving it through, or maybe relying on third-party libraries that do this mistake. So just like keeping your house key under your favorite plant pot or under the doormat. So how someone would hack in this case of vulnerability is using the SHA-1 protocol for password hashing. So what happens is when I give you a password, databases usually store the hash of this password and they don't store the actual password. If you are doing that, please don't do it. But usually the secure practice is to store it with a SHA-1 hashing mechanism. Hash is just like some kind of mathematical function that derives some unique string out of this password. So there can be a scenario where a user has already authenticated, but I need to authorize them when it's offline. I cannot communicate with the backend for this case, so I need to verify this hash, right? If your attacker somehow gets access to this local database and he figures out that you are using this SHA-1 hash or this MD5 mechanism, so it can run something called as a rainbow table attack. So basically, rainbow table, what happens is it just works on a principle that you take this SHA-1 and you compare it with publicly available hashes or SHA-1s on the internet. Like lots of these are available on the darknet or Telegram like that. So this is like a very small string. Like it's very easy to compare and it takes a very short amount of time and there are automated tools available for it. So this is like a outdated protocol and if your backend or your frontend is using this thing, you are not supposed to use it. And these hashes are also available for sale and hackers keep buying it in bitcoins or whatever currency. So how do you prevent it? You need to use modern solutions like PBK2F. So PBK2F is just like your SHA-1, but it's like SHA-1 multiple times and it also uses SHA-256. So what happens is it generates 256 bits of hashes, which is a little bit difficult and needs more computing power to actually figure out. Or better even let the backend do it for you, don't store anything on the front end. And ask your users always to kind of fix their own passwords and keep switching them. I mean, if you use Chrome, Google keeps on telling you, these passwords were found in a breach, just keep switching randomly. And this keeps happening, like these systems keep evolving. So keep rotating your passwords. And yeah, again, basic solution baseline is use obfuscation, encryption aggressively wherever possible. So yeah, in all, human errors keep happening in the system, as I said, because humans are the most compromisable asset of any kind of system, the weakest link. As developers, what we can do is we can conduct regular audits. If you have a security team, keep talking to them, keep knowing about what's latest that available in security that you must take care of, what's the best practice and all of that. And do not trust anything blindly from other apps, just randomly clicking links or just spread this awareness around as much as possible. And even if that means that you have to become the government and before each call that you make and you have to ask Amitabh Bachchan himself to give some kind of awareness. And I mean, just saw this meme where people got so happy. I love this meme because people got so happy when the government decided that they're not going to play the music anymore. I mean, don't do this. This is a very bad idea of enforcing awareness. But yeah, I mean, just wanted to end on a funny note. So, there you go. That's it for the day. I guess if you have any questions, please let me know. That's it for the day. Yes.
How to safeguard our app from reader-based injections? Like we can run some random JavaScript queries in like Flutter apps. If I decompile it, and I have seen attackers doing that. It's available in YouTube as well. So how to safeguard our app from?
So I think in this case, play integrity helps. Like when you run, I guess Frida. One thing is that. Frida doesn't work reliably over above Android 9 if I'm not wrong. Like last I used Frida, it didn't work for me above Android 9. But yeah, what I had read, like I'm not the best person for the security advice, but what I had read is play integrity covers this check, like it prevents doing it. Matlab Frida actually kind of runs some server by injecting some server into your Android system, right? So play integrity kind of avoids those kind of checks or does some kind of fraudulent activity. Like if I give you an example, as I said, there is this project called Revanced. It runs something very similar to Frida, मतलब जो code injection अपन करते हैं, ठीक है? So what they do is using play integrity, if they determine that some kind of code is happening, so what happens is if let's say I'm trying to play the next track in YouTube. So what happens is they've written custom code where instead of playing the next track, they'll play 4 times the next track. मतलब वो 4 बार वो next track को click करेंगे. मतलब they've literally added code in all of that. मतलब play integrity helps you detect. So you have to frustrate the users. Basically, YouTube has worked that way. They frustrate the users that use all of this hacky kind of stuff. मतलब at least play integrity kind of helps you detect that. Is what I'm saying. Yeah. Any more questions? Yeah, sure, please.
Once I was also working on the security thing,
Yeah.
I decompiled Rapid.
Okay.
And I was able to retrieve the API keys for Google Maps.
Okay.
So what I got to understand that if any API key is required on the manifest, if we are required to put it on manifest, we cannot directly obfuscate it or do some alteration. So how to secure those keys apart from server
I use something currently called as Google Maps का setup plugin है ना एक. I think you also use that for one of your repository.
Yes. Google Maps actually asks for applications SHA1 or SHA256
In the manifesto, na?
in instigate like wherever we generate API key.
I think on server level, like
Yeah,
SHA
yeah.
you have to compare, like similar to plain DLT but on server level check.
हाँ.
But कुछ API keys होती है जो वो checks avoid कर देती है. Apart
उसके लिए there are two things. One is this Google Maps का setup plugin आता है जो Google ने बनाया. ये लोग क्या करते हैं? They use NDK और C++ level stuff to actually let's say have you seen your local.properties file? So there are a lot of properties file. These are key value pairs. तो अगर आप उसमें रख रहे हो and you're using these plugins, what they do is these plugins will bundle those keys on the runtime. मतलब they will not expose them as strings. मतलब when you decompile that, it's not very visible. मतलब generally you discovered all of that just with that string search, right? So it won't be easy for a string search to do it. Basically, this is how all those plugins work. या फिर आप manifest में variables भी use कर सकते हो. Like there is a $based variable जो आप use कर सकते हो. I think clever tab के keys वैसे ही configure होते हैं. Like you make a .properties file for it and then you pick it from there. So that it's not easy for the hacker to just do a string search and just get to it. I think I'm not sure if this can be avoided, but this can be prevented. Like मतलब rather not prevented but avoided. Like I mean ऐसा समझ सकते हो कि मतलब उसको पूरी तरीके से रोका नहीं जा सकता, but हम delay कर सकते हैं I guess as far as I know.